All right, so I am unable to be in class today or tomorrow, March 19th. So I'm going to go over your homework for you, since I won't be able to answer questions in class, and then hopefully you'll be able to do the assignment for today. So number 13 says, Childbirth Part 1. There is some concern that if a woman has an epidural to reduce pain during childbirth, the drug can get into the baby's bloodstream, making the baby sleepier and less willing to breastfeed. In December 2006, the International Breastfeeding Journal published results of a study conducted at Sydney University. Researchers followed up on 1,178 births, noting whether the mother had an epidural and whether the baby was still nursing after 6 months. Here is the results. So we have whether or not they had an epidural and whether or not they were breastfeeding. What kind of test would be appropriate? First question I would like to ask you is, what kind of study was this? Was it an experiment, or was it an observational study? Was it a sample? Those are types of questions you need to start asking yourself now as we're preparing and getting closer to the UP exam. So they did an observational study because they didn't make people breastfeed or make people get an epidural. So it was an observational study. What kind of test would be appropriate? So I think you can make an argument for both the independence and homogeneity test. Is breastfeeding at 6 months independent of having an epidural? Or you could say, is breastfeeding at 6 months the same amongst those who had an epidural and those who did not? So let's write the hypothesis for independence. Now, I said in my PowerPoint that if you had one sample and several different variables or 2 different variables, then that was more an independence. And here we had one sample of 1,178 women, and they were asking 2 different questions from them, and so that's usually the independence test. So A is going to be independence. And your null hypothesis is that breastfeeding at 6 months is independent of having an epidural. And it's breastfeeding that's the independent, because the epidural is what they believe causes the breastfeeding to possibly not be as effective, or the baby to be lazy, sleepy. So, and then the alternative, breastfeeding at 6 months is not independent of having an epidural. All right, so number 15 then continues this discussion. In exercise 13, the table shows results of a study investigating whether after effects of epidurals administered during childbirth might interfere with successful breastfeeding. We're planning to do a chi-square test. How many degrees of freedom are there? So let's pull in the equation, or the table, real quick. Let me grab this for us. That way we can use it. So we have rows minus 1. So A, degrees of freedom, is rows minus 1 times cells minus 1, or columns minus 1, sorry. And that's 2 rows. Okay, we do not count 1, 2 rows, 1, 2 columns. We don't count the totals. So that is 2 minus 1, 2 minus 1 times 2 minus 1, which is 1 times 1. Degrees of freedom is 1. Now the next question is, the smallest expected count will be in the epidural node breastfeeding cell. What is it? These are typically good questions because they want you to actually calculate it by hand. So you want to know how to do it. By hand, it's column total divided by the table total times the row total. And the one we're interested in is the epidural no breastfeeding. Epidural yes, breastfeeding no. So it's the 190 column, or the cell, but we want the numbers here. We want our table, or cell column total, 396. Our table total, which is going to be 1178, times our row total, which is 474. And I get, I put it in my calculator and I get 159.34. And part C says check the assumptions and conditions for inference. So I realize my handwriting is terrible, so I'll type a few of these out. It's data is in count of a categorical variable. We have the sample, we're going to say is representative. It doesn't say they did a random sample, but it was definitely a large sample. And it says the smallest expected count would have been 159, so we can say expected counts are greater than 5. And then we would say, hold on, let me move this up so we can, never mind. So since conditions are met, I'm going to spell out chi-squared because I don't have a chi button on here. Model is appropriate. Even if it tells you on an AP question that the assume the conditions are met, you want to say since conditions are met and name the test. I will use a chi-squared test for independence. Okay, so let's move on to the next question, which was 17, dealing with the same problem. In exercise 13 and 15, we've begun to examine the possible impact of epidurals on successful breastfeeding. Calculate the component of chi-squared for the epidural no breastfeeding cell. So the chi-squared component is when we take the individual value and we do chi-squared component is the observed minus the expected squared divided by the expected, just for one of the cells. So for this one, my observed is 190. My expected is what we calculated on the last page. So it's 190 minus, pull up my calculator here, 159.34. Square that value and divide by 159.34. So minus 190, I get 30.66 divided by 159.34. I have to square the 30.66. I get 9 39.96 divided by 1, 59.34. 159.34, my calculator, and I get that chi-squared is 5.899, and it tells us that's just for this one part of it, only for that one cell. And then it says for this test chi-squared is 1487. What's the p-value? So for B, it would be chi-squared CDF 14.87, comma e to the 99, comma 1 degree of freedom. Okay, so when I plug that in my calculator, I get 1.152 times 10 to the negative 4. And then it asks me, state my conclusion. So let's move some of this up so I can type it in here. So since my p-value of 1.152 times 10 to the negative 4, where's my negative, is less than my or we could even say is so small on this one. So small, I reject the null hypothesis. There is not enough evidence to convince me. No, I'm sorry, I messed that up. There is enough evidence to convince me that breastfeeding at 6 months is not independent of having an epidural. And that's my conclusion. Since my p-value of 1.152 times 10 to the negative 4 is so small, I reject the null hypothesis. That means I don't believe they are independent, so there's enough evidence to convince me that they are not independent, and make sure we state our context in there. Okay, and the last question you had to do was the Titanic problem. Here is a table we first saw in Chapter 3 showing who survived the sinking of the Titanic based on whether they were crew members or passengers booked in first, second, or third class staterooms. If we draw an individual at random, what's the probability we will draw a member of the crew? So, a little bit of review of our probability skills here. What's the probability of it being a crew? And there's 885 out of 2,201. B, what's the probability of randomly selecting a third class passenger who survived? So third class who survived is 178. So that's third class and survive. So that's 178 over 2201. C, what's the probability of selecting a randomly selected passenger surviving, probability of surviving given they were first class. So that's the probability. Oh, we don't need probability equations for this. We can just look at what we've got. So we're only going to look in the first class column. We're not going to look at anything else. And what's the probability that, given they were first class, they survived? It's 202 out of 325. And you can use your calculator to get those decimals. D, if someone's chances of surviving were the same regardless of their status on the ship, how many members of the crew would you expect to have lived? That's asking for the expected count for the crew who lived. If they were independent, you would expect the percentage of those who lived to be the same amongst all groups. So we want to know what is the expected count for the crew who lived. That's the 212. And so we're going to do the column total, 885, over the table total, 2201, times the row total, 701. And we'll see what that is. Okay, so in my calculator that was 281.87. So you'd expect about 282 to survive if it was independent. State the null and alternative hypotheses. So I'm going to move this writing up now for a minute. My HO is survival, was independent, of class on ship. And the alternative is survival was not independent of class on the Titanic. So give the degrees of freedom for the test. Degrees of freedom, we have 2 rows, so 2 minus 1. We have 1, 2, 3, 4 columns, 4 minus 1. So that's 1 times 3. So there's 3 degrees of freedom. This is E. This is F and G. The chi-squared value for the table is 187.8. That's chi-squared. And the corresponding p-value is barely greater than 0. So it's almost 0. What are our conclusions? So, since our p-value... Okay, I decided to spare you watching me type. Since my p-value is barely greater than 0, I reject the null hypothesis. There's enough evidence to convince me survival was not independent of class on the Titanic. And that's our conclusion. So I hope this helps you get through the homework for today and last night.